Hello, let's implement k-means clustering with Python. So let's go collab.research.google.com/create equal new. Okay, and then let's name it as file name as k-means clustering class. Okay. First, let's import user libraries. So import numpy snp numpy library, and then skitlearn clustering library. So let's import from run dot cluster import k means. I think this is right. K means, and then graphics visualize from import math plot library pipeline splt. Okay, and then code. Let's generate simulate data. Let's simulate data. Okay, and then simulate the data of 3 clusters. So we basically, our idea is that we simulate the data of 3 clusters, and given the data, we will find that 3 cluster with k-means. So we are using 2-dimensional, so like ax and then ay. So they are a cluster. So x axis, so 2D values for A clusters, XY, so AX, AY. So basically, and then we will generate 2D values for B clusters and then 2D values for C clusters of AXY. So they are A axis and A Y axis, and then they are B x-axis value for B cluster and y-axis value for B cluster, and then C. So C, X, C, Y. And then we can generate some random number. So let's say they have clusters around, let's say this is around 60, and then 60, around the 60. And then this is around, center is around like anyone. So like -20, and then 100. And then third one is, let's say it is a bit small one. So like 10, and then -10, right? They are centers, the centers of clusters. And around these centers, we will generate random number with a normal distribution. So like, let's say standard deviation is 8, and then random number NP random, and then standard normal, And then let's say size is like 100. Okay, 100 values. And then same. So we are basically generating 100, like 100 data point for A cluster. And then B cluster similarly. B cluster for this one, let's say 80. And then, and then plus 80. And then full clusters like 5, let's say 5. And then for this one, sample size is now, same, it should be same, 80. And then this one is, let me say 77. And then 77. Okay, so we simulated data. And then to collect the data, let's concatenate data. So x is NP, and then basically concatenate, and then all x values, ax, bax, and bx, and then cx. And then similarly, we concatenate y values. So ay, by, cy. Okay, so save. And then let's generate now data. Data is data. Data is like together. So zip of x and y. Okay. And then let's look at the data. So now data looks like this. So data. So from tabulate, import, tabulate, and then tabulate data. Okay, so data looks like this. So x-axis and y-axis, good. And then like this. So now we have data. So next step, we just simulated data. Next, we regard the data given and we will undertake clustering analysis with the data. Okay, we are going to do that. Okay, so to do the clustering analysis, okay, first, let's see the graph first. Let us see the graph first. So to see the graph, I think, so PLT scatter X, Y. So yes, clearly we have 3 very distinctive data. Wow, it is such a, maybe too far from each other, maybe. Well, in that case, maybe we can increase. You can increase. I think I can increase maybe data. 1,000 more data, like 10 times of data. And then let's look at this. We have now more data. Okay. And then, well, maybe too much data. Let me reduce that again. And then to make close each other, let's make it a bit smaller. So how can I make this? It is maybe too large, like 20, 20. And then it is 30 and 10. Yeah, I think now it is slightly more challenging, but too much challenging. So let me again make it minus 20. Okay, and then if we do this one, okay, now it is getting better. So it is appropriate challenging, but yeah, but not so much challenging as a example. So actually a bit more. Okay, I think they are fine now. So we have clearly 3 clusters. So this is data, given data. So we will see whether our program can make 3 clusters well. So let's make graphic better. So let's make a better graphic. So better graphic. So subplot, and then AX, and then scatter plot. So scatter plot is like this. So now we will see only AX, AY, AX and AY, AX, AY, and then color. Let's say color is I think, well, orange maybe. So plus. Okay, so we have orange, and then B. Let's add B. This one is, we think, sky blue. Okay, and then third one, CX, CY. This one is which color? Yellow, green. Okay, this is good. Okay, so we have 3 colors, and then we can add grid. I think we can add a grid so the color is grid. Color is maybe gray. Sorry. Yeah, gray. Sorry, we always need this one. Quotation. So we've created, gray is like too strong. So let's make line style. Line style. Okay, and then how about line style? Maybe we can reduce line width. Line width is 0.5. Okay, now it is much better. And then alpha 0.5. Okay, so now it is much better. Next, okay, what we can do is actually AX pines, AX pines. And then you can reduce top, and then set feasible, and then force, okay, and then right. Well, it doesn't change much, but anyway, so we have a graph. So we have three distinct cluster, and then we will see whether our data do good clustering. So let's add code. So our first step is, well, instantiate the model. Well, usually we have to do trial and error to see how many clusters we have, but here, well, let's assume that we know the number of clusters. Of course, which is the most challenging part for k-means clustering, but for this one, let's assume we know the number of clusters, which is 3. So k-means, and then k k-means, and then n cluster 3. Okay, we have 3 cluster, and then next we set up the model. So fit the model. We fit the model. So we k-means is the name of the model. So we fit the model. So we fit, and then we fit the model with the data. So name of the data is appropriately. It has appropriate name of the data. So yeah, data. So we fit the data. Yeah, so we fitted the data. So we will see next. Let's see the center of the clusters. Print. Let's see k means k means cluster centers. Okay, so cluster center is minus 19, sorry, 10, minus 20, 19, and 21. So we know the exact center. Exact center is 20, 20, minus 20, 30, and 10, minus 30. And then, yeah, it is the 10 minus 30, minus 20, 30, 20, 20. So it is reasonable cluster, but it, of course, it's not exact because it is simulated data. So whenever we do the simulation, we will have a different number. So let's do the simulation again. Then again, we will have a different number. So again, we will have a different number. So on average, I think this will find the right centers, cluster centers. So let's centers of clusters. Oops, centers of clusters. It is not pretty, so change line. So center of cluster looks like this. Yeah, center of clusters. There is center of clusters. And then we will see the label of the clusters. Label of clusters. Label of clusters. And then tabulate k-means. And then we will see labels. Print. We have, so let me delete tabulate. Okay, so we have a label of clusters. So, well, we have how many data? We have 180, 77. So 257 number of data. And for each 250 number of data, we have a cluster. So this is a second cluster and first cluster and zero cluster. Okay, so we have labels of clusters. Okay, and then we have labels of clusters. So using the labels of clusters, now we can plot the data by labels, I think. So code, what we can do is plot the data by estimated labels. So basically, label is basically our estimated cluster membership. Label is cluster membership. Okay. So, well, so length of label. Labels is length of label is we can regard it the length of k means dot labels. Okay, here the length of so length of labels is, as we know, it is 257, right? And then our estimated one. So, well, we have A, B, C. So, where we can call A X, A1X, A1Y, and the B1X and B1Y, and the C1X and C1Y. So they are our estimated membership. Okay. So we have data. So first one is here. So X is so AXI, and then for I, and then in range length of labels, and then for each I, and then when label is 0, we will make it the AX1. Okay, actually it is a 2. Okay, so it is a 2, so it starts from 2. So and then and if k means labels equals what? Equals okay, I is one. I is equal to what? Equal to 2. Then it is a-axis. Okay. And then we copy, paste, and now it is y. And then k means label I equal 2. Okay. I think it is right. And then for B, estimated membership for B, well, I think the better strategy is delete this one. And then I can change it to the B, and C, and C. Oops, C. And then this one is now it belongs to C1 and it belongs to 0. Okay, so we have estimated membership. So I think we can generate graph again. So let's generate a figure. such that, well, for scatter, again, PLT scatter, and then A1X and A1Y, and now we have color is, what is the color of A? Color of A was orange, right? So orange is, let's match it to red. Okay. And then second B was sky blue. It was sky blue, so it is, let's say it is blue. Okay. The third one was yellow green. So the C is green. Okay, so we have this one. And then of course we have centers, right? So for centers, let's define center. So the center x equals I 0. First term for I in K means cluster centers. Okay. For cluster centers, we pick those in the cluster centers. And then Y, center Y is also in the cluster centers. Cluster centers. And then change line. We pick the cluster center such that PLT scatter center X and center Y. Yes, well, it is not so clear. I take center Y, and then let's say marker is X. We have strange center values. Center values are a bit strange. Okay. So for this one, this should be 1. Now we have marker, and then let's make color is black. Oh, sorry. Color is black. Yeah, we have X, but they are too dark. So let's make it a light one. So instead of red, let's say pink. Instead blue, we have, and then instead of green, let's have lime. Yes, now we have more distinct, center values. And then let's make it size a bit bigger, size 100. Okay, now it is much better. So we estimate the centers we have again. So, well, this is the data. So this is the data. Given the data, actually we exactly identify the cluster, and in each cluster we identify the centers. Okay. Well, let's make it a bit prettier. to make it a bit prettier. So let's import Seaborn as SNS, and then SNS Seaborn set, and then scatter plot. Let's copy this one. We can make it slightly prettier. So SNS and then scatter plot. SNS scatter plot. And then SNS scatter plot. And we run it. Well, it's slightly prettier. Oh, we have to put center. So let's make it pink. Pink is a bit weak, so let's make it gold. Okay, and then let's put center. Plot, scatter plot. Yes, I think it looks better. And then we learned how to do k-means clustering. So let's think about how to use this idea for trading. So trading ideas. Trading ideas upon clustering analysis. Okay, stock trading possibly it could be a bond or anything, but let's say stock trading ideas. But of course, it can be more general. Stock trading. Oh, sorry. Actually, I can add a text, not this one. So stock trading ideas. Stock trading ideas upon clustering analysis. How to use clustering analysis for stock trading. So what we can do is we can cluster stocks based on their financial information, like ROA, like leverage, ROA, leverage, and then, well, PER, price earning ratio, and on possibly on qualitative information extracted from like a big data, possibly, not always possible. So cluster stock based on their financial information and on qualitative information extracted from big data, possibly. Second, what we can do is examine the relationship between your clusters and then what? Well, you want to make money. So, and their returns, their cluster, so it is cluster returns. Cluster, return their, and the return of the clusters. Okay. So this generates trading strategies. Trading strategies across clusters, i.e. cluster level trading strategy. Hence, each cluster becomes your portfolio. Okay, so it is like you can generate. So you have a cluster. So for each cluster, you can investigate what has been the performance of the clusters. So you can like predict what would be future return of each clusters with like simple time series analysis, for example. So on time series analysis, okay. There's possible another strategy. Another strategy could be another strategy. Note that the stocks in the same cluster, if stocks are in the same cluster, are supposed to be similar to each other, right? They are similar to each other. Therefore, they are in the same cluster. Therefore, their stock, therefore, the stocks in the same cluster, the stock returns should converge. The returns of the stocks in the same cluster should converge in the long run, right? Not in the long run, maybe possibly in the short run. So let me delete this one. 그죠? Is are likely to. So note that the stocks in the same cluster are supposed to be similar to each other. Therefore, the returns of the stocks in the same cluster are likely to converge, not converge, converge. Converge, right? Then what kind of trading strategy you can make? Okay. Okay. So what we can do is therefore find out which stocks are overvalued or undervalued based on possibly by looking at their recent stock return performance, a recent stock market performances or financial ratios, right? Or valuation ratios. 뭐 이게 valuation ratio. So if stocks are in same cluster, since they are similar, they should converge in terms of valuation. So to find out which stocks are overvalued or undervalued, we can look at their recent stock market performance or valuation ratio. Then this generate, of course, this generate what? This generate trading strategies within clusters. Trading strategies within clusters, i.e., it is like a firm level, stock level, individual stock level. Previous it was a cluster level trading strategy, but now we have stock level trading strategies. Trading strategies in each cluster. Okay, so thank you.